Today we're going to go over the answers to quiz 4, and I would just have you take note of how I go about doing this, because I think we still need a little bit of study in these two sections in organic chemistry. There will be questions like this on the final, so please try to make sure you take note of these things. So let's take this first one. We want to find the name of these following compounds. So let's write this first one down. And I'm going to show you the way I do it in terms of figuring out the best way to get the right name here. And so first of all, you write it out, you have it written out like this. And I always focus on this part, because this part tells you what this is. This tells you this is an ester. Okay? If you have a C double bond O like this, you have an ester. And you remember that an ester is a combination of an acid and an alcohol, which is an organic acid plus an organic base or an alcohol. And that the division point between the two, the acid and the alcohol, when they come together, is right here. It's where the oxygen snatches onto the carbon here, not the double bond. It is not where the double bond is. It's where the single bond with the oxygen is. And that represents what used to be the alcohol, and then the rest of this is what used to be the acid. Now, the reason that's important is the first part of the name is based on the alcohol. In this case, it was methanol. Now it's methyl. And the latter part of the name is based on what the acid used to be. This used to be butanoic acid. Now it's butyrate. I don't know if I spelled I don't know if this is a U. I think it's a U, actually. It's butyrate, okay? And I accepted some variations on that. As long as you got the butane right, I gave it to you, whether you said butyrate or not. So when you name an ester, you have to recognize it's an ester first, and then realize that it's a combination of an alcohol, in this case methanol, and an acid, in this case it started out as butanoic acid, because there's 4 carbons here, and then that converts to butyrate. So that's how you name that one. This next one it looks like this. I'm just copying it down again so I can make, and this is the functional group that defines what this is. If it's on the end, it's an aldehyde. If it's anywhere else, like in the middle, it's a ketone. And the name of an aldehyde is the number of carbons, 1, 2, 3, 4, 5, so pentane. But instead of ANE, it's pentanal, AL. And that tells you it's an aldehyde. OL would be an alcohol. Al is an aldehyde. The third one here is an ammonia with 2 groups attached. And the easiest way to name this is you recognize this is now an amine, M-I-N-E. And the easiest way is to say methyl, because this is a methyl group, ethyl, because that's an ethyl group, amine. Methylethylamine. So that's the names of these 3 compounds. Now let's move down to drawing, and the idea is the same, okay? This one right here is the only sort of ringer I put in here to separate the A+ students from everybody else. But so this one, the rest of these are pretty basic. This one, you have 3-methyl pentanoic acid. So you start out with the idea that this is pentanoic acid. So it has 5 carbons. Okay, I'm not going to draw the hydrogens in, okay? And it's an oic acid, so on one end or the other, I don't care which end you write it on, you have the acid group, which looks like that. And then it tells you that on the 3 carbon, now in the case of a 5 carbon chain, it doesn't matter where you start counting, but in all situations, you are supposed to start counting on the end that has the functional group. So it's the 3 would be here, but if you started over here, you get the same place. So in this case, it doesn't really matter. And so it's 3 pentanoic acid. The next one is ethoxypentane. Okay, so you have, again, pentane, which looks like that. And then ethoxy tells you it's an ether, and it's ethoxy, and so it means you have a ethyl group. So it's ethyl pentyl ether, or ethoxypentane. Now, this tert-butylamine, amine, first of all, is NH2, and attached to this is a tert-butyl group. And the tert-butyl group looks like this. It's all the carbons around it like this. And this is to distinguish from one that might look like this, or one that might look like a straight chain of and so this is called tert-butyl. I think this one's sec, and this is N, or normal, okay? And so tert-butylamine means that there are 3 methyl groups around a single carbon attached this way. This is just something you would have known having studied that in the book. Okay, so let's go here. Now, again, if you look in the book and the material that we were studying, you'll realize that the combination of 2 alcohols to produce water produces an ether. And what happens, and I'm going to draw it just a little bit different to try to help with this. 1, 2, 3, okay. So you have an OH here, and then I'm going to draw it like this so that we keep it straight. Where the one too many there. So anyway, you have 1, then the OH group, this, and then this, okay? And the water, and it doesn't matter how you do this, but the water comes out like that. And so what you end up with is C-C-C-O-C, and then you have, but it's on the second carbon, not on the end carbon, like that. And so that is what happens when you put 2 alcohols together. Remember, an alcohol plus an acid gives you an ester. 2 alcohols combined together give you an ether. The next one is 2 oxidations. I explained this in an email to Elizabeth that I copied the rest of you to. And basically, with each oxidation, you either remove a hydrogen or you add another oxygen. And so the first oxidation, if you have this compound right here, you start out with an alcohol. If you remove this hydrogen, so the first oxidation will result in an aldehyde in this case, because it's on the end. So you've lost these 2 hydrogens, and you've ended up with this, okay? Now, if you further oxidize, you're going to add an oxygen here. So it's going to end up being an oic acid. And so the result of 2 oxidations is a compound that has 2 oxygens instead of 1 and less hydrogen than the previous, okay? And you have to look at it that way because the actual oxidation number of carbon never changes. The second one, you have 1 oxidation. The prediction would be Well, basically, you could just, well, let me do it this way so it's not confusing. You start out with your OH on the second carbon here. This is a 2. And this is now going to lose the hydrogen, but instead of an aldehyde, it's going to be in the middle, so it's going to form a ketone. So it's going to look something like this. Not something like this, it's going to look like this. And so please review this in the book so that you get the idea that if you go reductions, you're going this way, back toward more hydrogens and less oxygen. If you get oxidations, you're going this way.